3 point charges plus q, minus 2q and plus q. So here we have 3 point charges plus q, again plus q and minus 2q, and their locations are given. Okay, one charge is located at 0 y 0, so this is the charge 0 y 0. Then we have another charge 0 comma 0 comma 0, and we have another charge, this is a comma 0 comma 0, right? Respectively, the magnitude and direction of electric dipole moment vector of this charge are. So as per the question, right, so what is dipole? Dipole is two charges of equal magnitude but opposite polarity. This forms a dipole. So if I have this dipole, then its dipole moment is from negative to positive charge. Okay, so here we have two dipole, because here minus 2q charge is there. This can be written as minus q minus q. So here if I place one charge, then the dipole moment is will point in this direction, and if I place one another charge here, then the dipole moment of this two charge will point in this direction. So this assembly we can assume as two dipole which are perpendicular to each other. Okay, so because here you can see there are two charges. Okay, so here one dipole will form in the upward having dipole moment in the upward direction, and one dipole is forming having dipole moment in the x direction. So we have two dipoles which are aligned 90 degree to each other. We have two dipoles which are aligned 90 degree to each other. So the dipole moment of the first dipole, here it is minus q, here it is plus q, and here it is a. So the dipole moment of the first dipole is separation into q, and for the another dipole here we have positive charge at distance a. So again its dipole moment is p is equals to a into q, and here these two dipole have same dipole moment and they are at 90 degree. So and the dipole moment is a vector quantity, so net dipole moment of the system is p vector, p1 vector plus p2 vector, and p1 is nothing but q into a. So p1 square plus p2 square plus 2 p1 p2 cos 90. So the remaining part will be 0. Okay, so it is qa square plus qa square, so it is 2 into qa square and under root. So this will become root 2 into qa. So root 2 into qa, we have three options, right? But if you have one dipole, in the dipole moment is in this direction, one is in this direction, so by using parallelogram method, the new direction, the resultant direction of the dipole moment is in this direction. Okay, so it is along the line joining x equals to 0, y equals to 0, z equals to 0, means this point. Okay, here the point at the origin, right, and another point is lying here. So another point is at x equals to a and y equals to a. So x equals to a and y equals to a, because we are talking about this point, x equals to a, y equals to a. So the direction of the dipole moment is along this direction. So option number A is correct.